This lesson, we're going to focus on the conditions for parallelograms. In particular, with our last lesson, we focused entirely on if the beginning of your problem says you have a parallelogram. If you start by knowing it's a parallelogram right away, we do a whole lot of things. The definition told us that we would know that two pairs of sides are parallel. We would also know that opposite sides are congruent. We would know that opposite angles are congruent. We would know that consecutive angles are supplementary, and we knew that diagonals bisect each other. In short, when we knew that it was a parallelogram at the beginning, there was a whole lot of information that we got for free. Our focus today is working the other direction. You look at a shape, and it looks like it's a parallelogram. How do you know for sure? How do you know with 100% certainty that it absolutely has to be a parallelogram? Well, we have a list of 6 tools to do that. We, of course, would have the definition. If we can somehow show that both pairs of opposite sides are parallel, we know that it's a parallelogram. That's exactly what the definition is. We can also go through and show that we have one pair of sides that are parallel, and at the same time, that same set of parallel sides are also congruent. That would be enough to conclude with 100% certainty that our shape actually is a parallelogram. And we could go further. Both pairs of opposite sides could be congruent. Both pairs of opposite angles can be congruent. We can have one angle that's supplementary to both its consecutive ones. So one angle being supplementary to 2 different angles will get you there. And we could also have the diagonals bisecting each other. Well, please notice and compare the lists. The definition, we did that one yesterday. Parallel gives you this. Parallel gives you, parallelogram gives you, parallelogram gives you, parallelogram gives you. 5 of the things that we get from it being a parallelogram are actually biconditionals. They're forward and backward direction. They cause each other. And so what we will, of course, observe then that the only real new piece is this one. This is a set of conditions that we can use that, and it will show us why things are a parallelogram. Right? So with all of our problems, basically then, our one objective is, why is this thing a parallelogram? And this is our list of reasons why. All we're going to do is analyze the problem and see which one it fits. And I want to emphasize something. We don't need to go through and do all 6 of them. We need just 1 out of the 6. If any one of these things work, it guarantees us that we actually do have a parallelogram. And so, here we go. Show that quadrilateral PQRS actually is a parallelogram. Of course, our technique that we're going to look at the picture and start trying to figure out which one of these things on our list is going to work. When I look at the information here, I see a whole bunch of degrees symbols telling me that we're being given angles. If we're given angles, I'm certainly not going to do anything about having congruent sides. There are absolutely no diagonals drawn, so I'm not going to be using this diagonals one. And just by looking at the picture and seeing what type of information they're giving us, we can eliminate a crap load of the strategies as ones that aren't going to work. Additionally, when we're looking at it, I don't see anything that looks like it's going to get us parallel. So we're not going to use the definition. Because we're being given angles, we're right down at this point where we've got 2 tools for angles. Will we be able to get 2 pairs of opposite angle congruent? We're looking at the problem. There's absolutely no information being given about angle P at all. So if we have no information, I don't think that, just intuition-wise, I don't think that we're going to be able to use two pairs of opposites. So just by running through the picture and examining our list, we can pick the strategy that we're going to wind up using. We need to show that there's one angle that's supplementary to two other ones. And in order to get supplementary, they have to add up to 180. So that's what our whole problem is based on. Just by looking at the picture and seeing what we're given, we can figure out that we have to get angles adding up to 180. So let's start plugging them in. The measure of angle Q. Well, Q is 6 times y plus 7. So 6 times 6.5, that equals 39. 39 plus 7 gives us 46-degree angle. Continuing, measure of angle R. 15 times x, subtract 16. 150 subtract 16 is 134 degrees. Of course, we can go off and observe that if we add those two angles together, those are supplementary. So right there it is. We've got one pair of supplementary angles. Now we have to show that this angle R is supplementary to the other one. So the measure of angle S, 8 times y, subtract 6. So 8 times 6.5, that's 52. 52 minus 6 gives us 46. And so right there we go. This lets us know all the work in the red shows us that angle R is supplementary to angle Q, and angle R is supplementary to angle S. Since we have one angle that's supplementary to two angles, that forces this shape to be a parallelogram. And we're done. Please keep in mind that whenever you're working through these pieces, whenever you're explaining why something actually is a parallelogram, you're going to wind up referencing one of our 6 tools. One of the 6 is going to be used, so make sure you're writing it down, whether you're writing it down in words or in symbolic logic like I put up on the board, on the marker board for you. So what about here? Show that it's a parallelogram. Okay, when I start looking at this problem, the first thing I notice, I'm being given information about the sides. And since I'm being given information about the sides, it tells me I'm going to use one of the things about sides. I'm not using the diagonals. I'm not using those angles. I'm looking at this and saying right here, we have 2 pieces that talk about having sides. I need either 2 pairs of congruent sides, and because I'm not given any information at all about the top and the bottom, I'm not going to be able to get 2 pairs. So that lets me know if I can't get both pairs of sides congruent, the only tool that I've got left that's using sides is to show that these sides in the blue are congruent, and at the same time they have to be parallel. Okay, so let's start off. QP, which is 7 times A, 7 times 2.4, 14 plus 2.8 gives us 16.8. On the opposite side, RS, 2 times A plus 12. 2 times 2.4 would give us 4.8. 4.8 plus 12, 16.8. Okay, so we've got them congruent. One pair of congruent sides. How are we going to get parallel then? Because of course we don't have any of the tick arrows telling us. We're not given that they're parallel. But fortunately, we did spend all that time going over our parallel lines unit. We know that if we can get corresponding angles congruent, that forces parallel lines. We know that alternate interior angles congruent forces parallel lines. And the really popular one with parallelograms, same side interior angles supplementary forces parallel. So if we could show that same side interior angles are supplementary, we'd get our parallel lines. Well, of course, that's why we were given the interior angles. If we show that angle Q and angle R are supplementary, then we've finished our checklist. We know that this one works. So we'll say measure of angle Q, 10 times B minus 16. So 90 subtract 16 gives us 74 degrees. And of course we know the supplement to 74 would be 106. So as long as angle R comes up as 106 degrees, supplementary gives us parallel. Parallel combined with congruent gives us parallelogram. So let's punch the numbers here then. 9 times B plus 25. 81 plus 25 actually is 106. So we're observing then that same side interior being supplementary gives us parallel. And now we've finished exactly what we needed there. We have one pair of sides that's parallel and congruent. That forces this to be a parallelogram. Done. Remember, every single problem you're doing, you're analyzing it at the beginning and picking the strategy. Once you've got your strategy, it's just making sure that you check off the things that you need. Sometimes, getting that thing is really, really easy. Take a look at the numbers that we've got. Take a look at our list and see which one works. 107 plus 73 gets us 180. Those are supplementary. Those are supplementary. Right there. One angle is supplementary to two angles. Done. That's all we needed. It's just looking at it and figuring out what we need. Sometimes we've got to combine some algebra with it. What about here? Does this have to be a parallelogram? Again, pay attention to the directions. The last problems we're saying show that it is. Well, when it says show that it is, you know it's a parallelogram and you're trying to show why. These ones are asking determine if it is. So we're not being told it absolutely is or absolutely isn't. We have to run through and see which ones work. And if nothing works, then we can't know with certainty. Okay, we do have one diagonal drawn, and so that makes us suspicious. Maybe we are going to wind up using two diagonals. Well, the diagonals have to bisect each other. We have to know that the diagonals cut each other in half. If I draw in the next diagonal, how are we going to get information about length so that we know that the lengths are equal? We can't. Okay, since we won't be able to get information about lengths, we're not going to use that one. And in fact, there's no information about lengths anywhere, so we can't use congruent sides at all. Okay, so opposite angles being congruent. Here's one really important characteristic that we can figure out. And here's an observation that I got to give credit to Chance, because Chance was looking at this morning and he said, "Hey, Mr. Fry, what about this?" And so I'm giving him credit for this really cool observation that he noted. We have two triangles. One pair of congruent angles, two pairs of congruent angles. Because of the third angles theorem, we know that we would have a third pair of congruent angles. And then he observed, because it's basically each one of these pieces being the same size, the combined angles have to be the same size as well. It's like saying 1 plus 2 equals 3 on the top, 1 plus 2 equals 3 on the bottom, 3 is the same as 3. And with this observation that Chance made, he caught on to the fact that we have two pairs of opposite angles congruent. And so, right there, both pairs of opposite angles are congruent, so we would have the fact that because this one works, it does force this to be a parallelogram, and so yes, it is a parallelogram, and this is our reason why. Drawing in this information, catching the third angles theorem, catching the angle addition postulate, and forming the fact that both pairs of opposite angles are congruent, that's our justification. We know that it has to be. What about here? We clearly have two pairs of sides congruent, absolutely. One matches one, two matches two. Are those opposite sides though? Our theorem says they have to be opposite sides, and so this one and that one are opposite. Those are not congruent, and so this whole thing falls apart. Because they are not opposite, no. Must it be 100% certainty? No. We don't know measurements. This, by the way, would be a shape that's called a kite. We will actually study kites a little bit later on in our unit when we get into trapezoids also. But because they're not opposite, they do not have to form a parallelogram. All right, this one asks us, use the definition of a parallelogram. All right, so we're locked in right there. Use the definition means we can't use whatever we want. We have to do it this way. We have to show that both pairs of opposite sides are parallel. Well, keep in mind, when we're working in the coordinate plane, what do we know about parallel lines in the plane? They will always have the same slope. So if we can show that these sides have the same slope, that's going to give us parallel. All right, so what we're focusing on then is we've got this side KL connecting to LM, connecting to MN, connecting back, and cycling to K. 4 sides, and we can calculate the slope for each different side. And as long as we have 2 pairs of equal slopes, that gives us 2 pairs of parallel sides, and that, of course, is our definition. So we're going to have to start running through, get the slope. Remembering from our previous unit, we've got a slope formula. So we're just going to plug in a boatload of numbers. Take our y-coordinates, 7 minus 0, and the x's, -5 subtract -3. That's 7 over -2. Okay, moving to the second slope between L and M. 7 minus 5, -5 subtract 3. That's 2 over -8. Okay, going to the third set. m and n. Negative 2 subtract 5. 5 subtract 3 gives us negative 7 over 2. And at this point I'm observing 7 over negative 2, negative 7 over 2. That's one pair of parallel sides. Their slopes match, that's one pair of parallels. Progressing to our last one then, nk. Negative 2 subtract 0. 5 subtract negative 3 gives us negative 2 over 8. And we've got the same situation. We've got a second pair of equal slopes. That's a second pair of parallels. So all this stuff down in the blue says, since we've got KL parallel to MN, and we've got LM parallel to NK, matching slopes give us parallels. We would know that KLMN is a parallelogram. The definition tells us. And here's our last problem of the day. Legs in a keyboard tray are connected at their midpoints. I want to emphasize connected at the midpoints. Why does that force PQRS to be a parallelogram? Well, if they're connected at their midpoints, the midpoint means that the left and right hand sides are the same. And so left and right hand sides are the same. If we fill this thing in, why does the red have to be a parallelogram? Because the diagonals are bisecting each other. And we know that when diagonals bisect each other, that forces it to be a parallelogram. That's it, we're done. Every single thing you're focusing on is going to boil down to working with one of these 6 things. The skills you're developing are analyzing the picture and figuring out which one of the 6 is actually useful here. And depending on the problem, it's possible that you could have 2 of them that are useful. If 2 of them will work, then go ahead and pick the easier one. Pick which one that you see and that you know will work. Sometimes there's only one way to do it though, which of course is why you need to know all 6 methods.